record third period, but as soon as I stopped it, it vanished. So I have no idea what happened to the recording previously. So hopefully that will not happen this time, which is again why I'm recording now. Okay, well, hope everybody's having a great day. How was that quiz? Okay, not too bad, not too bad. Okay, hopefully the class averages are going to be, relatively the same. We'll kind of see that. So we are going to go ahead and almost finish up piecewise functions today. We'll go ahead and conclude that tomorrow. We'll definitely have some time in class, so we'll probably have the opportunity to go over questions on the assignment together. Remember, that's not due. The key has already been posted. In fact, if you're looking for additional problems beyond the homework, I don't have it pulled up here right now because I had to shut my computer down, but I did upload 2 different versions of a piecewise functions quiz that I'm not going to have time to give you prior to the test with the keys if you want to go ahead and take a look at that as well. Okay, it could be very, very similar to what you're going to see on the test. Any questions about the test on Thursday? I'm sorry? Everything we've done so far, the 3 lessons. So it'll have piecewise functions, language of functions, and graphs of functions will all be on there. Okay, that's coming up. Friday, we're turning in our focus activities. There should be 4 by that time. Tomorrow, you're getting the 4th and final one. If you want to turn those in early, you are more than welcome to. What else do I have up here? Please remember, if you're turning in your homework, fantastic. Thank you very much. Go ahead and keep it up. But I'm old-fashioned. Go ahead and make sure to give me a hard copy of it. Okay. Don't worry about submitting it online. Just go ahead and give me a hard copy. Yes, ma'am. We got these notes starting yesterday. So I should have some extra copies over here on the door if you'd like to take a look real fast. And I think that's all I got, unless anybody has any questions about what's coming up. Okay, well, let's see what we have here. Now, every class was different. I've already got A written in. Did we finish A? So we did finish A. Good, good, good. Okay, so we've got B, where we're going to do the same thing. We have another piecewise function here, and I want to write out basically the function for each of these pieces and then the subdomains that they belong to. So why don't we go ahead and write out just the functions, and then we'll come back and worry about the subdomains. So this one here, this is a parabola. So definitely we have to be altering x squared in some way. But to make it easier, I'm just going to go ahead and tell you flat out there's no dilation here. This is simply a translation. So knowing that, I would go ahead and just write it using vertex form. Does anybody remember the vertex form of a parabola? Vertex form of a parabola. Would be parentheses x minus. Okay, what squared? What do we call the vertex of a parabola? We use different letters besides x and y. H and k, there we go. And then that would be plus k. And you always have a scale factor a just in case there is a dilation. But in this case, remember I said there was no dilation, so a is just 1. So basically that can disappear. So looking at this, if I know the vertex of this parabola, I could just plug in and I've got my function. What is the coordinates of the vertex? It is 0, -3. There we go. There's my h, there's my k. And when you go ahead and plug this in, if it's 0, some people prefer to have the 0 there. You can simplify it. X minus 0 would simply be x. So I'm going to go ahead and say x squared plus -3, so minus 3. So this is just the parabola parent shifted down 3 units. Okay. All right. Now, there are other ways to go ahead and write the function for a parabola. You could write it in standard form. You remember the ax squared plus bx plus c version. That would take a little bit of work because you need to create a system and have at least 3 points in order to help you do that. So that's why, whenever possible for a problem like this, I would go the easier route, vertex form or something like that. Okay. Now, we had this piece that was the furthest left, so that was the top row. Now, middle piece, and then we'll finish up with the right piece, so the last one in our function. So, what kind of line is this? Yeah, it's just a horizontal line, right? In fact, if I extended it, what would it be? Where would it be hitting the y-axis? So this is just f of x equals -2. This is another example of there's no value to plug into, the y value is constant. Okay. Now this one over here, okay, this ray, because it's hard to tell, but that is a arrow, or at least I'm going to go ahead and believe it to be an arrow. You could go ahead and draw the line all the way through. If you're accurate enough, you could go ahead and figure out where the y-intercept is. I'm going to go ahead and do it algebraically, just to go ahead and get a little bit of practice on that. We can do one of two things. We can either use point slope and then rewrite it in the form of slope-intercept, or we can just plug directly into slope-intercept, y equals mx plus b. Jasmine, what would you like to do? You want to use slope-intercept. Okay, so here we have y equals mx plus b. All right, well, I'm looking at this line. We could use 2 points and find the slope, but it's probably faster, just to go ahead and choose perfect points. My rise and my run. What would that be? It's just 1. That's easy. So my slope is 1. Now, all I need is a point off of that ray. Doesn't matter which one. Tucker? What point would you like to use? Some point off of this ray. Okay, she wants to use 6, 3. Okay, so 6, 3. So there's the x and the y value that we're using. So see, we have all the information, which is going to help me figure out what that y-intercept is. So y equals, 3 equals, well, I'm going to take slope times x, so 1 times 6 is just going to be 6, plus b. So it looks like my y-intercept is going to be what? -3. That's what it be. Okay, now I'm going to go ahead and just take the slope and the y-intercept, put them together in y equals mx plus b, so I should get 1x minus 3. And if I go ahead and continue to draw this down, it should be hitting at -3. Okay, all right. So any questions on how I got any of those 3 functions? Easy, right? Now, graphically, normally they would exist everywhere for their domain and range respectively, but I'm looking at this piecewise function. Each one's been restricted. What's the subdomain for x squared minus 3? Where does he live? There you go. He is going to go to negative infinity, but he definitely stops at 2, so I'm going to go ahead and say this. Now, because that's a closed circle, I'm going to put a bracket on that. Okay, where does -2 live? What interval can he exist in? Yeah, it looks like he only exists from 2 to 5. And open circles tell me they would not be included, so parentheses. And where does the ray live? From 5 to infinity. There we go. And because it starts with a closed circle, I'm going to put a bracket, 5 to infinity. Okay. Questions? All right. Well, that's pretty straightforward, okay? Writing a function, getting the subdomains from a graph. Now let's reverse that process. Given the piecewise function, let's go ahead and sketch this. All right, so this piecewise function is going to be made of 3 different graphs. We've got a quadratic right here, absolute value, and then finally we'll finish up with a cubic. Now, I would, strongly encourage you, anything you remember about these functions, like characteristics, anything that's going to quickly give you a point or make it easier to sketch, definitely go ahead and use. But I would also encourage you, use the boundaries of their respective subdomains, because we do need to know the point where it either stops and or starts. And I'll show you what I mean. Let's take a look at this first one. So it is quadratic. In fact, does anybody recognize the form? It is vertex form. Okay. I can tell just by looking at this without doing any work, the negative tells me it has to open down. The 1/2 is a dilation. So that's going to be a vertical compression or stretch. Compression, so I know the parabola would have to be slightly wider than the parent. And there's my h and my k. What's the vertex of that parabola? -4, +3. In vertex form, remember, you're still taking the opposite of the x value, but the k is as it looks. So -4, +3. Okay, so there's my vertex. All right. Now, what I would go ahead and do, I'd go ahead and turn my attention now to the only boundary I have. The graph only exists less than or equal to -1. So let's go ahead and say that the quadratic is A, absolute value is B, and the cubic is C. That way we can just keep our work kind of straight, looking at our paper. So I'm going to look at A. I'm very interested to know if I were to plug that boundary into this function. When x equals -1, well, what y value do I get? Okay, so let's see here. -1/2 times x plus 4, so that's -1 plus 4, and then I'm going to say plus 3. Okay, and now we just want to go ahead and simplify it. Does everybody see what I'm doing? Taking the boundary and I'm plugging it in. Well, let's see, negative, oh, and I forgot the square too, sorry. So -1 plus 4 will give me 3, 3 squared, 9. So I have -1/2 times 9 plus the 3. And let's just go decimal on this one to make it go faster. That'd be a negative what? -1.5. There we go. -1.5. So I have a point on this function. I know that when x is -1, I have the corresponding y value -1.5. Now, what does the inequality tell me about this point? Would I mark him with an open or a closed circle? Closed. We have equality. Okay. So -1, -1.5. Okay. Now, here's what I was referring to a moment ago. I mean, I could go ahead and continue plugging in values of x, finding points, but I think there are easier ways to do it. Like, one characteristic we know about a parabola is that there's always a line of symmetry going straight through the middle, right? How many points minimum do you need to graph one? Just 3. And see, I've already got 2, right? So if I know that this guy opens down and his line of symmetry would be right here, well, all I got to do is reflect this point over. So it looks like he's 3 units away, so 1, 2, 3. There you go. See, I'm trying to make it as easy on myself as I can. No need to make it any more difficult than it might already be. Okay. Now, I'm not going to even go ahead and draw the whole thing. Now I'm looking at the subdomain. He can only exist less than -1. So I'm going to start here. Probably something like that. There we go. And remember, these are just sketches. If you want to go ahead and find more ordered pairs, to make it that much better, fine. Okay, you don't have to. All right. Let's move on to B. Now, both B and C are very similar to A in that you can still determine the center or the vertex of those graphs. Okay? Even though this is absolute value, this is still my H, this is still my K. So where would the vertex of that absolute value be located? +2 and then -4. Okay, so +2, -4. So right there, again, just looking at the function, I've already got a point guaranteed on the graph. Okay, so where else do you think I would look to get a few extra points to help me out here? What did we do for the quadratic? There you go. See, for the quadratic, we plugged in his boundary, right? Well, here we have 2 boundary values that we can go ahead and plug in. All right, so let's see here. Here's B. So I'm very curious what happens when x equals -1. So I'm going to plug it in. 3, absolute value, -1 minus 2, and then -4. X equals -1. We're using the lower boundary first. Okay. So let's see here. What would that be? What would the value of that expression be? It would be what else? Oh, not -1. 5. There we go. It's going to be 5. So I know an ordered pair that I can use is -1, 5. Now, what does this inequality tell me about that point? Open or closed? Open, okay, because it's less than. The -1 I plugged in is not included. So -1, 5, I would put an open circle at that location. Okay. So now I would use the upper boundary. So I'm very curious what happens when x equals 4. I'm going to plug it in. 3, absolute value, 4 minus 2, and then -4. What's that going to give me? That will give me 2, yes. Okay. So this gives me the ordered pair 4, 2. And it looks like, again, just like the -1, that would be an open circle as well. We're strictly less than 4. So I'm going to say 4, 2. There we go. And what shape does an absolute value graph have? It has the V. Well, if we know this point here, 2, -4 is the vertex, Then I'm just going to go ahead and connect those with segments, and there's my V. So anybody who's not sure what I'm doing? Any questions? Okay. All right, let's take a look at this last one, C. This is a cubic, so let's talk about the parent. Several people today have not remembered what the cubic looked like. So x cubed starts in quadrant 3, curves up through the origin, and then up through quadrant 1. X cubed looks just like that. Okay. Well, even though it's a different function, well, it's still of the same form. I can find the center of this graph after those two translations. Anybody tell me where would that center have moved to? Positive 6, positive 2. There we go. Right there. So that's a guaranteed point on that graph. Okay. Well, now what do I do? I go ahead and look at the boundaries of my subdomains. Now this one, we want everything greater than or equal to 4, so I only have 1 to plug in this time. So for part C, when x equals 4, let's see, 4 minus 6 cubed, and then plus 2. So let's see, 4 minus 6, negative 2 cubed would be a negative 8 plus 2. So that'd be a negative 6. Okay, so 4 would give me the point 4, negative 6. Now we do have equality, so this is going to be a what? Closed. So I'd say, was it 4, negative 6? Closed right there. Now that's where it begins, because this graph can only exist from 4 onward. Okay, and I know it's got to curve up to the right, so I would probably say it's going to look something like this. And you'll notice I didn't bother putting in an extra value of x past the 6, or even, smaller than the negative 4 on the quadratic. You're more than welcome to do that if you want to, but these are just going to be sketches, and I think that's perfect enough. Question. Well, would there be a point at 7, 3? Okay, so when x is 7, yes, there would. So let's see, 7, 1, 2, 3. Oh, man, how awesome am I? Are you just using points now? 5, 1. So I'm a little off on that one. Okay. I'll still take it. There you go. There you go. All right, close enough. There you go. I know that seems sketchy, but I guess it's a drawing. Yeah, all right. Sketchy. All right. Applications from real life. In the land of Leibniz, I don't know if I'm pronouncing that correctly, a person filing taxes as single pays taxes based on the following table. Okay, so what you're going to notice, the first 2 columns are going to be your class intervals or your brackets. Okay, so depending on which one the person falls into, this third column is the expression that you're going to go ahead and use the formula to determine the amount of taxes paid. The only thing is, you can't forget about this last column over here. It says the tax rate is this, but of the amount over. So that's key. Okay, now for part A, we don't need that last column, but that definitely is going to be super important when we go ahead and try to figure out how much taxes a person who makes $68,750 is going to pay. All right, so part A says, okay, write a piecewise function, t of x, giving the tax owed by a person whose taxable income is x, when x is less than 125,000. So all it wants you to do is take the information in the table and go ahead and create a piecewise function like we've been working with. Okay, we've got 3 rows of information, so we're going to have 3 rows in my piecewise function. Okay. Now, the first part is going to be the formula, the expression that you would use depending on the bracket. So I'm going to be looking at column 3. Can anybody tell me for the first row right here, the first piece, what would the formula be to find the amount of taxes somebody pays between $0 and $30,000? Does it give me any information for that? How much will the person have to pay? 15% of the amount they make. But what represents the amount they make? X. There we go. So the first one is going to be 15% of however much money they made. Okay. Now, of course, this value of x is going to have to fall between 0 and 30,000. So I'm going to go ahead and say 0. Now it says at least, but not more than. So I'm going to write it out as 0 less than or equal to x less than 30,000. Okay. Because, see, we definitely don't want to include 30,000 here because 30,000 is going to be included on the next one. And what if the person made 30,000? Well, what bracket is it going to fall into? That's why, it's going to be a nice, smooth, continuous class interval, but where one ends, the other is going to have that value. Does that make sense? Okay. Can anybody tell me what would the second row be? Okay. So I heard 0.20x, 20% of the amount they made plus $4,500. Okay. Now, you're only going to use this formula if they fall into what interval? 30,000 to 65,000. So I'm going to say 30,000 less than or equal to. So see here, at least this amount. So I'm going to include him here, but I'm not going to include the upper value. Is everybody okay with how I'm doing this? Okay. And what would the last row look like here? Okay, so 0.24x plus, we got 11,500. And what's my subdomain? There we go. Perfect. So there we go. We basically just reorganized the information. Okay. Now, let's look at B. This is where the last column is going to be really important. It says evaluate the function to find the tax owed by a single person whose taxable income is $68,750. Now, I'll let you guys decide. Would you like to do this together, or would you like me to give you a minute or two to try it on your own, and then we'll come back? Tucker, what do you think? Individually? I like the way you think. All right. Okay. So I think that last column, it's the amount over the minimum value of your bracket, the tax bracket. Okay. So let's see. Okay, let me go ahead and catch up to you real fast. So the first thing to decide is, okay, which formula are we using? First, second, or third? Okay, third. 68,750 belongs to this interval, so I'm going to be using this guy right here, just like yesterday when we were doing the function notation. Okay, but here's what I'm going to do. This person guaranteed is already paying $11,500, plus we're going to take 24% of 3,750. Where did I get that number from? Okay, because it says of the amount over. So you'll notice 0, 30,000, and 65,000, those are the minimum values in your sets. So if they made 68,750, okay, I'm going to subtract off the minimum value for that interval, 65,000. Okay, see, that's what it's meaning in this particular problem. Okay, like let me give you another example. Let's say somebody made $35,000. Okay, what bracket does that fall into? The second one. So if I wanted to calculate how much money they got to pay in taxes, It would be the $4,500 that they would have to pay plus 20% of what? Only 5,000, because that's the amount over the minimum in that bracket. Okay. Did anybody catch that when they created the problem? That one's been tricking a lot of people today. All right. So how much would they be paying in taxes? $12,400. That is exactly right. So see, that last column really didn't come into play until you were actually going to try to calculate how much a person owed. Why wouldn't you do what, man? You could if you wanted to. Somebody asked me about that earlier. You could go ahead and put in parentheses, like here, 0.24, parentheses, x minus 65,000. You could go ahead and incorporate that if you wanted to. Okay. That's absolutely fine. Not a problem with that. All right. I think we only got the one problem left, and that, with our last focus activity, is what we're going to focus on tomorrow. Okay, so if you're feeling ambitious, you get home tonight and you're like, wow, I want more math. You still got this problem if you want to look at it. If not, that's fine. We will take a look at it tomorrow.